Me podcast with Phil Zito, episode 339. Hey folks, Phil Zito here, and welcome to episode 339 of the Smart Buildings Academy podcast. In this episode, we are going to go through energy management for BAS professionals. We're going to go through our 4-step process related to energy management. And by the end of this episode, you should have a list of ideas that you can implement with your customers or within your own facilities in order to better manage your energy. As always, everything will be available at podcast.smartbuildingsacademy.com/339. Once again, that's podcast.smartbuildingsacademy.com/339. I also encourage you on June 8th at, I believe it's 9 a.m. Pacific time, we are going to be doing an open house for Smart Buildings Academy. If you've ever wondered, what do we do? How do we deliver value? How do we train folks? We're going to look at that. But more importantly, we're going to talk about how to implement a training organization within your own company and how to kind of take some of the strategies we developed and apply them to your business. All right, let's dive into energy management. So this is a 4-step process. And why do we care about energy management? Well, if you've been following the news at all, you know that the cost of natural gas, the cost of electricity has gone up, as well as supposed rolling blackouts that are going to be coming, at least to the United States, over the next several months. Places where we never thought we would see outings or rolling blackouts or brownouts, potentially are going to see them this summer. So all of that brings us to a need to actually implement some energy management strategies that can go and benefit your business, can ultimately make things a little bit better for you. And this all starts with step 1, which is evaluating the opportunity. Oftentimes, I will see folks throw out the let's put in analytics, or let's do a retro commissioning, or let's go and do an energy study. In actuality, the opportunity may be as simple as implementing scheduling. It may be as simple as going and taking everything out of hand. It may be as simple as going and raising the temperature set point or lowering the temperature set point at certain times during the day. So the first thing I want to get out of everyone's head is that, you see all this crap out there being pushed about electrify everything, green energy everything. You're going to have to report on greenhouse gas emissions as part of an ESG rating of any publicly traded company. There's all this stuff, and it can feel super intimidating, and it can lead to people taking no action. When in actuality, there's often, even in organizations that feel like they're more advanced, there's often low-hanging fruit. I did business with a major automotive manufacturer who was known for their energy efficiency throughout their organization. Yet this same automotive manufacturer had a building that for several years was running. It was on, it was occupied, and the lights were on, the HVAC was on, and no one was in the building. And I know that seems like a highly unbelievable story. It's really nuts that this could happen in a Fortune 100 company. But the reality is, if that's happening there, where they actually have a budget to have an energy management team, and they actually have sustainability goals, and they have sustainability oversight, how much is it going on in an office building? How much is it going on in a small school district? So we want to evaluate the opportunity. How do we evaluate the opportunity? An opportunity for energy management comes from typically 3 things: people, processes, right, and purchasing. So you can renegotiate purchasing. I would say that right now would be a very poor time to renegotiate purchasing, but there are organizations that renegotiated a guaranteed rate for utilities a couple years ago when utilities had dropped, and they signed an agreement for multi-year utility rates, and they are definitely benefiting from that right now. We're not going to really focus on the purchasing side of things because in at least today being June 1st, 2022, that option really is off the table for us right now, unless you are willing to gamble that rates are going to go significantly up and you want to lock in the current rates. That option of purchasing lower utility costs is not really optional, or not really a good option, in my opinion. So that leads us to people and processes. In my experience, people have been the greatest barrier to energy efficiency within a building. That had to do with organizational buy-in, that had to do with technical acumen, so technical capability and knowledge to actually implement and execute and maintain, because that's the big thing. We're going to talk about strategies you can implement right now, but actually maintaining those strategies over time, that's where the energy savings. Anybody can go and change schedules. Anybody can put VFDs into soft start things. Anyone can go and implement resets to reduce consumption. But as soon as the energy managers left, as soon as the company who's implemented this left, did these things remain, or did they go back into just controlling things in hand? I'm reminded of when I lived in Wisconsin, my kid's school district at the time did an energy savings contract for 5 elementary schools. And they were really shocked as to why they weren't meeting the savings. I mean, on paper, everything made sense. They were going to reduce energy spend. They were going to put in controls. Everything was going to be great. But in actuality, the 65, I think it was like 68 actually, year-old engineer would go into the crawl space of the schools and still every morning would go and manually adjust valves. Therefore, taking this energy savings and just throwing it out the window because these systems were no longer controlling. Excuse me. They were no longer controlling how they should control. And this created some major issues. Because if you know anything about energy savings contracts, they're guaranteed. The energy savings contracting company has expectations of which the owner has to perform, and they get their profit from the savings that are created. They get a portion of the savings, as well as the portion of the savings pays for the energy contract. So that was the huge issue, was personnel. Which brings us to step 2, which is identifying the change. So, right, we've evaluated an opportunity and we've deemed that, we're paying a higher dollar per square foot, so you can do dollar per square foot, or you can do consumption/demand per square foot. So kilowatt/kilowatt hours per square foot. It really just depends. I tend to like demand and consumption per square foot because depending on what part of the world or US you're in, the dollar per square foot could be deceiving. But if you go into things like Energy Star and you start to look at averages for consumption and or demand per square foot by vertical market, you can start to get a pretty good idea. There's also a bunch of Department of Energy data on this as well. You can start to get a pretty good idea for what is a targeted demand and consumption for your vertical market. For example, a data center is going to have a much higher demand and or consumption rate per square foot than a warehouse, right? Just the energy density per square foot is going to be significantly higher. So we need to account for that. And that's how we evaluate. And it's my personal favorite way to evaluate our opportunity is not against some arbitrary sustainability goal, not against some arbitrary target, but rather to look at the market and see where are other people at, because you can go and drop yourself significantly below other buildings from a consumption or demand perspective in the market, but is the ROI there? Is that going to potentially impact the environment? And also, is it going to potentially cost you more than the return on investment? Once you've evaluated the opportunity, and you do indeed believe that there's an opportunity, which, by the way, for those of you salespeople out there, you can simply go and request energy bills from customers, get their square footage, and figure out what the opportunity is. If the average, and I don't have this memorized, but if the average is, let's say 10 kilowatts for every 1,000 square feet. I don't know. I'm just spitballing a number here. And you go to a building and it's 20,000 kilowatts for the square feet. I know that's insane, right? Kilowatts being demand. That would be an insane amount. But like I said, we're just spitballing here. You notice that there is a potential opportunity. So then you can go and discuss this potential opportunity with the customer, and you can show the potential savings both in demand rate charges as well as consumption charges, as well as any time of use charges, which we'll talk about in just a second. Once you've evaluated and identified the opportunity, then you need to identify the change. Knowing that demand is high and or consumption is high, and or both of these are high at a specific time, is really going to enable you to drive your strategy. Because there are strategies to reduce demand, there are strategies to reduce consumption, and there are strategies to change time of use. Let's kind of clarify what each of these terms mean before we go a little bit further into the podcast. So demand is the amount of power that needs to be provided to your facility to meet the demand. Consumption is the amount of actual power that is being consumed by devices. So demand is measured by kilowatt and consumption is measured by kilowatt hours. Time of use is when you are using that demand and or consumption. There are things called ratchet clauses, which if you exceed demand by a certain amount, then the utility provider is going to raise the minimum amount of demand that you have to pay for. And they're going to do that because if you've exceeded that demand, then they have to account for potentially having to provide that much demand to you again. So they're going to charge you for that. So one of the best ways to avoid cost increases is to manage and or lower demand so that you don't get bumped up into a higher demand rate. Now, consumption is another thing that we can adjust, and that is the consumption of electricity and or natural gas for our HVAC systems. And then finally, we have time of use. Here in Arizona, you have summer time of use and you have fall and spring time of use. And if you are within those time of use windows, there are different levels. And in those windows, you're going to pay different rates. I think, if I remember correctly, there's a specific time of use window in the afternoon where it can almost get to 20 cents a kilowatt hour. It's pretty crazy. And, you can use renewables in the residential market to go and offset that. And you can also do other strategies that we'll talk about, things like ice storage, things like pre-cooling, things like using passive ventilation, things like using active ventilation in lieu of mechanical cooling. There's a variety of things we can do to mitigate our consumption and or demand during those time of use areas or periods. All right, so we need to identify the change. We need to identify what are we trying to change. So we've evaluated the opportunity. We've identified that either demand or consumption is higher than the current market standard for whatever vertical you're in. We've identified the change. We either want to reduce demand, we want to reduce consumption, or we want to change time of use. Now we need to go and calculate ROI. This is where we have the IPMVP, which I don't have that acronym memorized, but essentially IPMVP, as far as we're concerned, has three kind of M&V methodologies that we want to apply. There are four. There's option A, B, C, and D. D being whole building modeling using like DO2 and other building modeling software. We're not going to talk about that in this podcast. We're going to talk about A and B and C. So A is going to be M and V with a single variable. So for example, we may have an air handler and our single variable that we are driving towards is resetting discharge air temp. Ultimately, we're trying to reduce kilowatt hours. So we're trying to reduce consumption, but we are doing it with a single variable, discharge air temp. Option B would be multivariable. Maybe we're changing discharge air temp. Maybe we're changing the economizer to reduce outside air and mixed air temp, and all of that enthalpy load depending where you're at. But you have multiple variables. Option C is more of a modeling. So option A and B are more for modeling out your energy conservation measure, which is known as an ECM, but they are also for measuring your energy conservation measure. Now, option C is where we are going to look at the historical consumption and or demand. And what we're looking for here is we're looking for what is our baseline. We're doing what's called baselining. And then we're going to apply what is known as regression, which are regression variables. These may be things like occupancy. These may be things like outside air temp, outside enthalpy, etc. And what we're doing is we're collecting the utility consumption, demand and consumption. We're applying variables like outside air temp, occupancy, etc. And that gives us a more accurate picture of step one, the opportunity, and it enables us to better calculate the ROI. If we can assume that our energy consumption and demand are going to stay the same across a 12-month period, and we can account for temperature variables, we can build out a cost model. We can say, okay, this is what it's going to cost us for a year. Then using option A and or B, we can go and implement things like discharge air reset, economizer, chiller load management, raising our condenser water temperature, raising our discharge temperatures, using enthalpy control for economizer, CO2 control and reset strategies, demand control, ventilation, things like pre-cooling, things like increasing ventilation rate in lieu of temperature. And we can model these out and their effect, and then we can overlay that effect onto our energy model, our 12-month energy model, excuse me, and then we can figure out what the impact is going to be, and we can calculate our ROI. Now, things are a little crazy right now because the MBTU cost of natural gas and the kilowatt hour in demand, kilowatt costs are going up. They are variable. And depending on what happens in Europe, we may or may not see significant increases in those costs. So going and modeling things, I would say on the conservative side of things, if you do model things out, you stay at the rates we are right now, because most likely those rates are not going to decrease in the near future. I would almost be willing to guarantee that natural gas costs are only going to increase as we exit summer. And as there's more push for electric vehicles, as there's more push for electrifying HVAC systems, we are going to see an increased cost of demand and consumption, because naturally, as demand increases and supply stays the same, because it doesn't look like we're increasing our supply anytime soon of power, naturally costs are going to increase. So from a modeling perspective, if you stay with the current prices, you should be good for a rolling 12-month window. So, okay, we've evaluated the opportunity. We've identified that there is one. I've told you, right, you can go Department of Energy, you can go to Energy Star, et cetera, and you can pull data from vertical markets, data center, healthcare, K through 12, public, et cetera, and you can figure out, kilowatt and or kilowatt hours per square foot, MBTUs, so that's millions of BTUs per square foot as well. You can figure out all these numbers, and you can identify if the building you're looking at is significantly above other buildings. Then you can identify what you want to manage. Do you want to go and avoid demand ratchet charges? Do you want to go and reduce consumption? Do you want to adjust for time of use? What do you want to do? Once you figured that out, you can calculate the ROI. But in order to calculate the ROI, you need to identify your strategy. As I mentioned, there's 3 strategies: reduce demand, reduce consumption, and change time of use. Let's talk through each one. So reduce demand. Let's go through that strategy. So demand, once again, is the amount of power the utility has to provide us in kilowatts in order to meet the demand of our building. They need to be providing us enough power, enough kilowatts for if we decided to turn all our chillers on at the same time or all of our air handlers on at the same time. Now, how would they know what that amount of demand is? And this comes into our first strategy. Typically, they measure demand in 15-minute increments. So they'll look at 15 minutes. So that's why the general strategy when you're turning on your buildings, not only is to soft start things, have VFDs, because what happens is you have full load braking amps, or maybe it's called braking amps. And braking amps, if I remember correctly, braking motor amps is 4 times the amp draw of your full load amps. That's typically the numbers. Like I said, I don't have this memorized, but I'm going back in the memory jars here. So you've got this thing where you turn on this motor, this compressor, this fan motor, etc. And what happens when you turn on an air handler in the morning, right? It ramps up to 100% because what typically happens, at least if it's in the summer, all the VAV boxes open to 100% because all the spaces have gotten hot overnight. So all the VAV boxes open up 100%. The air handler opens up 100%. The fan goes boom right there. And if you don't have a speed drive to soften this, what's going to happen is you're going to surge all of those amps and you're going to get that demand spike. Now, this isn't necessarily such a big deal if it's one air handler, but what if you're like this one church I did in Dallas where there were 24 air handlers and they all turn on at the same time? You get this massive demand spike if there's no VFDs on these. So one of the easiest ways to control demand is to soft start. That means to slowly ramp up the motor with a VFD, variable frequency drive or variable speed drive, and to have some sort of soft start logic. If you want to take it a step further, then you can batch that soft start logic across several units across 15-minute periods. Now, your utility will vary. I apologize, it's really dry in here. Your utility will vary. Some of them will have 15-minute intervals. Some of them will have hour intervals. It's up to you to go and figure out how they calculate demand and when they do it. But understanding that, okay, they're going to calculate demand every 15 minutes, every 10 minutes, every hour. Well, I'm going to go and stage because it may make sense for you to stage your air handlers over 2 hours and avoid demand charges, or stage your chillers over an hour and avoid demand charges because demand is pretty expensive, and take the hit on the consumption side. This is something that you'll have to measure and you'll have to figure out, but that is the first strategy, right? Is reduce demand. And we reduce demand, one, by soft starting things. This is why VFDs are such a good strategy. Not only do they reduce wear and tear and give you better controllability for some of the consumption strategies we'll talk about later, but they also enable you to soft start. It's really, really a good deal. Now, that being said, we also can go and reduce demand of our full load amps by going and reducing the demand on the system. This may be looking at things like doing discharge air resets, doing temperature resets, economizing, etc. Now let's move over to consumption. Consumption is another topic that folks focus in on. So if I'm advising people, I tend to advise people, fix your time of use first, then fix your demand, then fix your consumption. Because time of use, especially if you're in California, you're in New York, you're in Arizona, that can whack you really, really hard. If you get in one of those like 2 or 3x time of use periods where you're, 20 to 25 cents a kilowatt hour, that's crazy. And you can like really ratchet your bill up super fast if you don't have kind of guaranteed rates. That being said, I'll come to time of use last because it depends on a lot of these strategies. So I've talked about demand. Now let's talk about consumption. Consumption is going to be the consumption of power, or MBTUs in the case of natural gas, in order to actually execute your conditioning, your mechanical cooling or mechanical heating. So there's only so many things that consume power and or MBTUs, natural gas, within a facility. The consumers of power are motors, right? Compressors, and that's pretty much it. I mean, yeah, you have boilers as well if you're talking natural gas, but those are the consumers, right? Your valves, your dampers, yeah, they consume a little bit of amp draw, but nothing compared to a fan motor, nothing compared to a compressor, a pump, I guess you could say as well. I just throw that in with fan motors. They basically do the same thing. They move water instead of moving air. And your boilers, right? Your heat generators. So if we know that, then how do we reduce consumption on those devices? Well, if those devices consume power in order to meet set point, we have a couple options. We can reduce set point, or we can be more efficient with set point. So let's talk about reducing set point first, and then let's talk about being more efficient with set point. So reducing set point is quite simple. I'm not saying it's comfortable. I'm not saying it's necessarily advisable, but it's quite simple. We can do things like reducing airflow. We can do things like reducing temperature set points or increasing temperature set points in the case of cooling. We can do things like raising our chilled water set point. Now, all of these will have a compounding effect on the environmental quality within a building. We can also do things like using free cooling, which I'll talk about in a second. Now, there's this delicate dance, and if you haven't studied ASHRAE Standard 55, I really encourage you to do it. ASHRAE 55 and ASHRAE 62 are two of my favorite standards because ASHRAE 62 really explains how much oxygen you need in a space, and a lot of people will just do the standard 10-15% minimum outside air damper and call it a day, when in actuality, depending on the type of space and whether it's persistently occupied or not persistently occupied, may not require you to actually use that CO2 and condition that space. So that's something, ASHRAE 62.1 you really should know if you call yourself a professional in this industry. ASHRAE 55 is really cool because it helps you realize, things like metabolic rate, things like ventilation rate, things like relative humidity, moisture saturation of air, and how all of that affects the evaporative effect, solar load, etc. And as you start to understand these things, you realize that you can have someone at 72 degrees 65% relative humidity. That's pretty high relative humidity. And they can feel crazy uncomfortable. And then you can have someone at 78 degrees, 10% relative humidity with a high ventilation rate. And due to the evaporative effect, they can feel very comfortable. And so you then have to ask yourself, is it better for me to reduce the utilization of my chillers and their compressors and increase my ventilation rate and raise my discharge air temperature? This is kind of one of the things you have to figure out. And understanding ASHRAE 55 can help you to figure that out. So there's this thing called the thermal comfort corridor. And if you go into Google, don't do it right now if you're watching the video and it'll end up pulling you out of this window. But if you go into Google and you Google ASHRAE 55 thermal comfort corridor, you'll see on a psychrometric chart the area of which thermal comfort is met within a building. That's why, I live in Arizona. If you go down to Phoenix, you'll see a lot of buildings that are 76, 78, and they're able to get away with it because the relative humidity outside is 5%. And so with that low relative humidity, that keeps that thermal comfort corridor at such a point that you're able to have a higher dry bulb temperature and still satisfy your tenants. So that's something to be aware of, is can I go and reduce my discharge air temperature? That is a consumption strategy. Going and reducing your chillers is a consumption strategy. Having a better lift on your chillers is a consumption strategy. All of these are consumption strategies because as soon as that chiller turns on, yes, there is a demand associated with pumps, with compressors, with fans, but that consumption can be mitigated. Demand can be mitigated, but consumption, that is a little harder to necessarily mitigate. But you have it's a little bit easier to mitigate than demand. Sorry, I got that all mixed up here. I've been talking for 30 minutes now and it all kind of blends together. All right, so we've talked about demand, we've talked about consumption reduction. Now let's talk about time of use. So time of use is typically in the afternoon and evening. So they will look at the kind of 12 to 4 p.m. period and then the 4 to 8 or 4 to 9 p.m. period. And if you are operating during these time of use periods and you don't have a guaranteed rate, then what can happen is there's a multiplier effect on your demand and your consumption rates. So what you want to try to do here is you definitely don't want to stand stuff up during this time period if you can avoid it. Ideally, what I see a lot of people try to do is subcool a building, maybe use ice storage and cool ice with their chillers because it's cheaper to run them at night, and then use that stored energy. Because what we have to remember at the end of the day, heating and cooling is all about energy transfer. We are converting electricity or natural gas into energy, right? In the case of heat, we're converting it into energy or in case of a boiler, we're converting natural gas or electricity into BTUs, energy that is then transferred into the hot water loop, which is then distributed throughout the building. In the case of chillers, we are transferring energy into a compressor and evaporator, which are running the refrigeration cycle, which is forcing basically heat transfer from the chilled water return into atmosphere, whether it's an air-cooled or a hydronically cooled chiller. So understanding those concepts, we can understand that with time of use, if we can execute our consumption and our demand prior to those time of use periods, then we are able to go and not be penalized as much during those time of use periods. So that's why I say time of use is my primary focus. The only reason I don't bring it up first is because it's not in every state or every country. So it is something to be aware of, but it's not necessarily something that exists in every state or country, but it does exist in enough that you should be cognizant of it. So to summarize this podcast, you should evaluate your opportunity. You can do that with Energy Star, with DOE, look up comparable vertical market buildings. Ideally, look at the demand and consumption per square foot and not at the amount of money, because that will give you a better idea of your energy density compared to other facilities. Identify the change you want to make, whether you want to reduce demand, consumption, or manage time of use. Calculate your ROI using IPMVP, option A, B, or C. There are calculators out there on the web that you can Google. You just Google IPMVP, option A, calculator, option B, calculator, option C, calculator, or you can just do the equation. It's a pain in the butt. And then step 4, you implement your strategy. In next Wednesday's episode, we're actually going to talk about analytics. We're going to talk about managing these kind of strategies. So I believe that will be episode 342. So we'll talk about the actual execution and management of these strategies, because that's where all this tends to fall apart. So establishing an energy management or getting adoption of energy management within your facilities. As I mentioned, we are having a live open house coming up June 8th at 9 a.m. Pacific time. I highly encourage you to attend that. I will provide a link in the comments and or on the podcast page, depending on where you're at. As always, you can find everything at podcast.smartbuildingsacademy.com/339. I appreciate you all being here. Let me know in the comments what strategies you like to implement, what strategies are you seeing adoption around, and what strategies are working for you in the area of energy management. I'd love to hear from you. I read all of your comments. Thanks so much for being here, and I will see you all again on Friday. Thanks so much, and take care.